Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski, right here, and you can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have links to online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. You are given that x and y both have the same uniform distribution on the interval 0, 1 and are independent. U is equal to x plus y and v is equal to x over x plus y. Find the joint probability density function of uv evaluated at the point 1/2, 1/2. Well, we have x equals uv and y equals u minus uv by solving for x and y, by finding the inverse of the transformation we are considering, and then we find the Jacobian of that inverse. That's the determinant of the partial derivative of the matrix of partial derivative of x with respect to u, partial derivative of x with respect to v, and in the second row of the matrix, partial derivative of y with respect to u, and partial derivative of y with respect to v. So partial derivative of x with respect to u, where x is equal to uv, is v. Partial derivative of x with respect to v, where x equals uv, is u. Partial derivative of y with respect to u, where y is equal to u minus uv, is 1 minus v. And partial derivative of y with respect to v, where y equals u minus uv, is minus u. And the determinant of this matrix is, well, v times minus u times 1 minus v. So that's minus uv minus u plus uv, and that's minus u. And the absolute value of that is going to be u. So this implies that f sub uv of uv is equal to f sub xy evaluated at x that corresponds to uv and y that corresponds to uv, times the absolute value of that minus u, the expression we just calculated. But the joint distribution of x and y is uniform on the unit square, 0, 1 by 0, 1. And actually their independence is just a product of 1 times 1, where the density of x is 1 between 0 and 1, and density of y is 1 between 0 and 1, and 0 elsewhere. So this is simply 1 times the absolute value of minus u, and so that's equal to u. And the density evaluated at 1/2, 1/2 is what you get when you plug in u equal to 1/2 and v equal to 1/2, and that's of course equal to 1/2 because u is equal to 1/2. And that's answer D. Please remember, this is copyrighted material. The problem itself comes from me, and so it's owned by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.